We're just going to take a look at the example we looked at today during the team test. So let's draw any quadrilateral. Not necessarily a parallelogram. Make sure it's different from my neighbors. And I'm going to go ahead and label the midpoint. So using the point tool, let's find the midpoint. Now I may have to add segments. Nope. It looks like it is happy to consider these polygon sides as individual segments and give me a midpoint. Okay, and then you were asked to consecutively connect the midpoints of the sides, so that's a particular direction. Now you were also given this information about the midpoint of a triangle. So let's take a look at a triangle, any triangle, and let's find the midpoints of the side segments of the triangle. And let's connect one pair of mid-segments. Whoops. What I know when I connect MN, because it is the mid-segment, definition being that it connects the midpoints of two sides, is that MN will be parallel to what I think this is JI, and it'll be exactly half its length. The parallelness can be applied in our quadrilateral. So segment M here must be parallel to segment E. So if I add a segment on top of EF and a segment on top of GH and a segment on top of AC, and then I go to the properties of those segments, it would be accurate to add a parallel decoration between these two, because AC represents the base of triangle ABC, and AF, oops, I need to get the point tool, so let's put that back on. So AC represents the base of triangle ABC. E and F are midpoints of sides AB and BC. So EF is the midsegment. Therefore, it would be accurate to add a parallel flag, and I think I used the 3. Maybe I only used 2. Let's take a look. Yes, 2 and 2. Now what's also true is that GH is formed by connecting the midpoints of AD and CD, which are the sides of triangle ADC. Let's make ADC a new color. Properties of ADC. I hope I'm in the triangle. I think I am. Nope, I'm in the whole figure. So let's go to figures. Quadrilateral, segment, polygon. Nope. Nope, it's this one that I want. Now, therefore, HG, the mid-segment of triangle ACD, the big pink one, is going to be parallel to the base, AC. HG parallel to HC. Well, that's interesting. Let's mark that as well by going to the properties of this segment. Properties. I think it's under style. I think I used the 2 flags. Okay, and even if I move these vertices around, the properties of parallelness will stay the same. Even if I collapse the vertices right on top of that segment. So maybe this is a parallelogram. What do you think? Can I, in the same way, show that segment EH is parallel to GF? I mean, it looks like I could bring them together in such a way that they'd be parallel to a line segment created from B to D. Well, let's try to reorient this triangle so we're looking at it in the same orientation that we looked at the first. Our original two segments still parallel to each other, still parallel to the base of the triangle, but the question is HE parallel to DB? Well, triangle DAB with base AD or BD exists. Let's highlight segment BD. I don't know, let's make it red. HE is created by connecting the mid segments of the triangle ABD, where sides AD and AB have mid segments H and E. Therefore, HE must be parallel to DB and half the length of DB, according to the triangle mid-segment theorem. So it would be accurate to mark these as parallel to the base. Object properties, style. Let's choose a different parallel flag. How about the triple? Oops. I'm not getting that. Okay, so I'm looking for segment DB. So I'm just going to go shopping for it over here. It looks like it might be A sub 3. That one will work. But I'm not getting the decoration tool. So A sub 3. So I'm looking for something with 6.99. Ah, that's interesting. No, I'm looking for something with 11.13. 11.13. I need a copy of you. Here's R, it's red, that makes sense. Object properties, decoration tool, I need the triple. Is it also true that triangle D, oh, I need the polygon tool, that triangle DBC exists? Let's make it a new color. Purple, maybe? And it has sides CB and CD, whose midpoints are connected as GF. Therefore, this mid-segment is parallel to BD. Now I'm noticing here that my arrows are pointing in different directions. I wonder if that has something to do with the way the mid-segment was chosen. It would be accurate to state these two parallel to each other. Interesting. Let's try this. If I draw a segment on top of EH, it's called S, and I've chosen the segment from right to left because I want to see if my arrows will point to the left. No, they still point to the right. So I haven't quite figured that out. But what I have shown is that no matter how I change the polygon, the quadrilateral, the original quadrilateral, because of the way the midpoints of the quadrilateral sides are connected and their relationship to the triangle created with the base along the diagonal, the interior quadrilateral must be a parallelogram. The second question asks you to consider what happens when you connect the interior of a rhombus and how you could generalize that idea. So remember that a rhombus is a quadrilateral that's also a parallelogram that has 4 congruent sides. So maybe GeoGebra is the way to go for this exercise. And I'm going to say using the properties of the triangle midsegment. Proof that the quadrilateral created by consecutively connecting the midpoints of any quadrilateral using the properties of the triangle midsegment. That is what this illustration shows.